This is going on page 49 when we're done. Okay, so like I said, continuing transformations, going to look at them from a table aspect today. What I want you to remember is that I have a sign up here somewhere, right? The process is more important than the answer, okay? On the AP exam, when you get points for things, more of your points are going to go towards your process and your work and your understanding of things than to the actual answer itself, all right? So your opinions on whether or not you should have to actually show things, totally irrelevant. Like, do you want to get the points or not? That's what it boils down to, right? So we want to make sure that we express ourselves correctly with correct notation and clearly so everybody can understand what's happening and that we don't have linkage errors, that we don't have things that we're saying are equal or not equal, things like that, okay? So keep that in mind as we go through this. So we're starting with example 6 because I think Friday we ended up with example 5. It says the table above gives values for function p, okay, and you can see that this is p of x, right, for selected values of x. So it's not saying that these are all of the x values in p, right? Could be. Could just be like a scatter plot. Could be a continuous function. We don't know. Doesn't really matter. Then it says let h of x, so the table's about p of x. We're talking about h of x equal this equation right here. We're going to find these following values. All right, so if I want to find h of negative 1, I'm going to write down h of negative 1 equals. Well, the way we do that is everywhere, since it's h of x, everywhere I see an x, I am now going to substitute in a negative 1. So this gives me 3 times p of 2 times negative 1 minus 1. First step, 0 work, substitute it in. Okay? Boom. You understand the process, right? So now, when I go to clean this up, can I multiply the 3 times the 2? No, that doesn't make any sense. So then I'm going to have 3 times p of negative 2 minus 1. Now can I multiply the 3 by the negative 2? No. Can I take the negative 2 and subtract 1? No, because p of negative 2 is a value. It's a y value, right? Where could I find that value? Up here, right? So this, in the table, here's negative 2, so p of negative 2 is 1. So this gives me 3 times 1 minus 1, which is going to give me 2. Make sense? We all good? You understand how to use the equations when you have transformations. You understand how to look at the table. You know where to find your stuff. Not difficult at all, right? But we got to show some stuff along the way as we do it. All right, so let's look at B. H of 2 is equal to, that means I'm substituting 2 in here, 3 times P of 2 times 2 minus 1. First step, 0 work. Then that equals 3 times P of 4 minus 1. Notice how I have equal signs in between each one of those things, right? Equals 3 times what? 3. Good. And where did you get that? From the table. And that's equal to 8. Okay? Easy enough? It really is that easy. There's nothing tricky about it. You just got to make sure, especially if the table maybe has like P of X and K of X and J of X in there, that you're actually pulling the right numbers, because sometimes that's where the weirdness happens here. All right, then you do C. Did you get -4? Well, good. Any questions at all? Okay, so what have you noticed along the way that I don't do with my answers? I don't box them, okay? Now, every now and then I might, out of habit, because it's a hard habit to break, okay? And so, sometimes I underline them just so that because I know you're looking down and writing and looking up, I don't want to lose you. But here's the thing with AP. I mean, and I've known this for years, even before I taught any AP classes, but I still, when I was teaching pre-AP, had my students box their answers in, because I want you to be able to say, hey, this is what I got. So you are encouraged on the AP exam not to box your answers, okay? And the reasoning behind it is kind of contradictory, if you ask me. So basically, if I did this and I've got 2 and 2 is not the answer and I have it boxed, I am saying 2 is my answer. But if I have the right answer somewhere, I still could get credit. But if I have 2 there, I still have the wrong answer somewhere, so I might not. So you see where I'm going with that? Like, it's just in case, I don't know. I think maybe it does give you a little bit of a chance if they're like, oh, I don't know. I mean, I don't know what to tell you, but the encouragement from the community is that we don't box our answers. Now, you want people to be able to find your answer, though. And so that's why I say somebody's got to be able to follow your work. We got to have equal signs. And even if you have bad handwriting and you can still, I mean, I can follow lots of things, all right? But you got to have it on there. It can't just be random gibberish. As long as it's like work, then it's totally fine, okay? So I'm not, and I haven't really said anything about it up until now just because I know that this class was very different from the very beginning and I didn't want to throw something else out there for you. I'm not going to ever say, oh, I can't believe you boxed your answers again and I'm going to count that wrong or anything like that. It's going to be a hard habit to break, I think, for some people. And maybe some of you didn't do that anyway. But just start trying to change that about your work. Okay? We're just going to kind of slowly try to get there. And like I said, every now and then I just, out of habit, might box mine. And you're not going to get it wrong. Like, if you have all the right stuff, whether you box it or not, it's not going to matter on the AP exam. So if you do it, I don't want that to be a matter of stress. That's another reason why I didn't make that big of a deal about it. Okay. So, and the other thing is, don't worry about, if you do have something wrong, you don't have to erase a hole in your paper, you know. Just mark it out. There has been some questions about, and I don't remember what class it was, I don't think it was all my classes, asking if you had to use pen on the AP exam. The answer is no. Is a pen going to be offered to you? Yes. But pencil is fine. I wouldn't be able to take a math test in pen, I don't think. And not because I need to erase, just because I'm old school and it was ingrained in me. But if you mess up, like you realize you plugged in the wrong thing or whatever, just put a big X over it and move on. But if you have something wrong on there, don't just redo it and have the wrong and the right. Like, you need to cross out the wrong thing. You don't have to scribble it out. You can just like put an X over it and you're fine. You move on. Okay? Just kind of get in that habit too. I know sometimes it's a matter of space, but we'll figure all those things out as we go. All right. So example 7. G is constructed by applying 3 transformations to the graph of F in this order. A horizontal dilation by a factor of 3, a vertical dilation by a factor of 4, and a vertical translation by -7 units. All right, and then they give me, it says, if G of X equals this. Are those letters, are all 3 of those letters the exact same letters we've been using in our transformations? Did we use a C? What is this C doing? Changing the Y value up and down, right? And that's where we put K. Even if I had taught you with A, B, C, and D, I would have used a D there instead of a K, but they have a C. Remember what I said? It doesn't matter what the letter is. It's where it is. It's telling you what it's doing. So if you were asked a question like this and they give you this, make sure you are putting the letters wherever they did with whatever the signs are. You with me on that? Because it's not meant to confuse you or be a trick, but it could be different than, you know, whatever your original notes say. Okay, because we could, like I said, we could use any letters we wanted over there to make it whatever we want. All right, but now it tells us just to find A, B, and C, but we're going to write the equation anyway. And it's an equation, so I need a G of X equals, well, I'm thinking about it, equation has an equal sign. It has a Y equals G of X equals, or I don't know, it doesn't even have to be a Y or a G necessarily, but on the test, quite a few people got points off because when you were writing the equation of the slant asymptotes when you did the long division, you didn't make an equation. An equation has an equal sign. What you wrote is an expression, and those are different, and you're not going to get full credit for things like that. So be careful. All right, so G of X. Now, this A, okay, where they have the A, what is that thing in general? Like, what transformation does the A do? Vertical dilation. Okay, and it says, I have a vertical dilation by a factor of 4. So do I put 4 there? Yes, 4 times f of. Then I have b. So what kind of transformation is this b? Horizontal dilation. So I have a horizontal dilation by a factor of 3. So do I put 3? No. What do I put? 1/3 times x. And then we already said, what does this c do? Up and down. It's a translation. So that's my vertical translation by a -7. So what do I put? -7. All right. So we wrote the equation. Did we answer the question? No. Okay, because you wrote an equation and we put a, b, and c in there, but we didn't actually say what they were. So then we just need to say that a is equal to 4, b is equal to 1/3, and c is equal to -7. Now, they could have given us this equation and put minus c there, right? And if they did, what would our answer for c be? +7. So just be careful with that. Make sure you're paying attention to what this says. Don't just assume it's written exactly like what you would be used to it written like. Okay, we good? Okay, good job. So let's look at number 8. It says the table above gives values for a function of h values, and then it gives me that same type of little equation here. A, b, and c are positive constants. In the xy plane, the graph of k is constructed. Okay. Phrasing like this sometimes I think confuses people. You read something like that and you're like, I mean, and it's not even and my point here is that that's not even that complicated or that confusing. But the fact that they stated it sometimes seems weird. Like, why are they telling me this? Of course it's in the XY plane. So don't take things like that and overthink them or make it, you think that it has to be difficult. It's just saying basically like what it says. In the XY plane that you've been graphing in your entire lives, the graph of K is made by this. So it's just kind of extra wording in there, not meant to confuse you, but don't make more out of it than what it really is. Okay, applying 3 transformations to the graph of H in this order: horizontal dilation, vertical translation. We want to find K of -6. But the first thing we want is K of X. So I want you to take that information, I'll give you a second, and I want you to write that equation. All right, do you agree with what I have? 3 times h of 2x plus 1? Yep. All right, so then we are going to find K of -6. So find K of -6. Okay, so the AP Pre-Cal stuff being new and there's not that much for us to look at, I can't necessarily speak to that, but I can speak to, there's a tons of questions like this in AP Calculus. Obviously the equations are different, we're doing different things, but we're doing the same type of thing with numbers from a table. And everyone that I have ever seen from years and years of material, the actual computation when you substitute stuff in should be fairly simple. Okay, so don't expect there to be like giant numbers and be weird things. Like it should be something simple to computate, because again, we are not testing whether or not you can multiply these numbers. We're testing, do you understand where to find it? Do you understand what you're doing? All that other stuff. Okay, so all the stuff should be pretty simple there. All right, any questions on that? Are we all good? All right, so let's look at, so I want you to go ahead and read example 9. See if you can get it started. I'll give you a second to think through it, and then I'm going to talk you through it. Actually, I'm going to while you're doing that, let me give you a second to think about it. I'm going to pass out this next piece of paper. Okay, so this one is very similar to the A, B, and C one, but it's different, right? So they give us this function, p of x, 3x minus 2, and the graph of R is the image of P after a horizontal translation of 4 to the graph of P. If R of x is in this form, find the values of A and B. Okay, so if I'm going to take, if I'm going to make a translation, right, and this is R of x, so my R of x then is going to be equal to this, but with a horizontal translation, right? And when I do that, I have to subtract or add to x, right? Would I be adding or subtracting from x? Subtracting. So do you think I just get to do, so like just put, do you think it is this? 3x minus 4 minus 2? No. Okay? If I'm going to just affect the x there, it's going to look like that. Does that make sense to you? That's my horizontal translation by 4. Now, in that form right there, can I just look at that and grab A and B off of there? Because is this the same form as this? No, it's not. Can I get it into that form pretty easily? Yeah. I just distribute my 3. This is going to give me 3x minus 12 minus 2. So then R of x would be equal to 3x minus 14. Now, when I look at this equation, can I see a horizontal translation? No, but it did happen, right? It's just in a different form. Okay, and then from this form, I can actually find A and B. A is equal to 3, and B is equal to negative 14. Okay, everybody okay with that? Any questions? All right, so that is going to go on the same page as Friday's. I just handed out the worksheet A2. I'm going to split you up into groups again. I'm going to tell you where we're going to start on this. Okay.